A really important term to know about when we're talking about using energy, and also a term that's really frequently misunderstood or misused, is the term power. Now, power is the rate at which you can transfer energy. So it has units of energy over time. So the SI unit for power is a joule per second, which is also known as 1 watt, which is named after James Watt, the Scottish engineer who designed a radically improved steam engine, which was a critical improvement to technology that spurred the Industrial Revolution. I suppose that since power is a frequently used term in normal language, it leads itself very naturally to misuse when we're talking about it in physics, but you need to be very careful to make sure that you're talking about the right quantity. For example, supposing you get a letter from your electricity company and it tells you that you have to pay a certain amount of money. You might be tempted to think that that is a power bill, but it's not a power bill, it's an energy bill. What they're charging you for is a certain number of kilowatt hours. And 1 kilowatt hour is the energy that you transfer when you have something that has a power of a kilowatt for an hour. So a kilowatt is 1,000 watts, a watt's a joule per second, and an hour is 3,600 seconds. So then you cancel the seconds and you end up with 3.6 million joules, which is a unit of energy. So it looks like it's got watts in it, but because we're multiplying by a time, if we take this time and put it over here, power times time is an energy. Think of a car. So in a car, the energy is basically your petrol. So you have a certain amount of petrol in your car and you're putting it out there because it's a really handy source of chemical potential energy that you're going to use to transfer into other more useful forms of energy like kinetic energy for your car. Or possibly it might be your batteries if you have an electric car. Whereas your power has everything to do with the engine. So you might be able to have very large batteries or have a large amount of petrol, in which case you can go all day, but it's your engine that tells you how much power you're going to have, and that tells you how quickly you can suddenly transfer some of that energy into kinetic energy. Human bodies transform energy all the time. We take in large quantities of energy. An average human eats something like 6 to 12 megajoules a day. And we process that and we use it for all sorts of metabolic processes, from healing to computation. And some of it's also used by our muscles to produce external forces on other things. But that's a surprisingly small fraction of our total power output, except for professional athletes or cyclists or something like that. But let's have a look at what our power output is averaged over the entire day. Use a round figure of 10 megajoules, so that's 10 to the 7 joules per day. And we need to turn that into seconds if we're going to end up in SI units. So we need 1 day, and we need to figure out how many seconds that is. So it's going to be 24 times 3,600 seconds. And so that means we're going to have 10 to the 7 divided by 24 divided by 3,600, and that's going to be, once we cancel the days, that'll be in joules per second, so that'll be in watts. And that gives us 115.7 watts, but we're not that accurate, so we're just going to say it's on the order of 100 watts. And the vast majority of those 100 joules each second go into low-grade heat. And so the human body is always putting out about 100 watts of heat energy, and that's what we have to dissipate into our environment. And so we have careful systems to make sure that we always are emitting about that 100 watts. It's very easy to see people with infrared precisely because 100 watts of infrared light is emitting off each person. If you get 100 people in a room, they're effectively putting out as much energy as a 10 kilowatt heater, which is quite a lot of energy, which is why rooms get very hot when you put lots of people in them.